All right, so this is the unboxing webinar for the Look Up First Image STEAM Activity Toolkit for NASA at My Library 2.0. Just a quick facilitator introductions. Should all be familiar with us by now, but my name is Claire Ratcliffe Adams. I'm an education associate at the Space Science Institute. I am joined today by Dylan and Christine, and I will let them introduce themselves. Pass it over to Dylan.
Hey everyone, I'm Dylan Connolly. My pronouns are he or they, and I'm an education specialist at the Space Science Institute. And I'm really excited to share our final NASA at My Library activity toolkit with y'all.
Hi everybody, I'm Christine Shupla from the Lunar and Planetary Institute. I'm one of the co-investigators for NASA at My Library.
All right, we are going to start with a little icebreaker to kind of introduce one of the topics of the First Image Toolkit, which is different types of stars. So what type of star are you feeling like today? The options are massive hot blue star, totally energized and ready to do incredible things, a binary pair busy with teamwork, our yellow sun, bright and sunny, or a red dwarf star, slow and steady, and able to keep going and going and going. So feel free to put your answers in the chat, or you can also unmute yourself. You do have microphone access. Christine is saying she feels like number 4 today, a red dwarf star.
I'm feeling a little bit like a black hole today, I'm not gonna lie.
Yes, you can also choose options not on this list. Stephanie feels like a binary pair, busy with teamwork. Karen, also number 4, especially the slow part. Red dwarf for me too, says Barbara, and I think I would have to say I'm kind of a mix between number 4 and number 2. Definitely lots of teamwork happening today, but feeling a bit slow as well today. And Susan shares number 2 today, the binary pair working on decorations for Oceans of Possibility, making a lighthouse. Very cool. All right, well, thank you for participating in that. We do have an activity we have a couple of activities actually that reference the different types of stars that are out there. So we'll be learning a little bit more about that, but thank you all for checking in with this icebreaker. I'm going to now turn it over to Dylan to give you an update on the James Webb Space Telescope mission.
All right, so I know it's been a minute since we've had one of these webinars talking about JWST for our NAML partner. So I thought I'd just give a brief recap of where the mission is right now. So we had a really successful launch on Christmas on December 25th in the early morning hours. And the sun shield deployment, secondary mirror deployment, and primary mirror deployment all went swimmingly on its way out to reaching its final orbit at L2, Lagrange point 2. On January 24th. So it took about a month to get to the final orbit position and get everything deployed. Next slide, please. So since then, they've been doing testing and alignment. We got the first aligned image earlier this month, and alignments and tests are expected to be completed sometime this summer, and the science mission is expected to start right as soon as that is done. So we're going to be hopefully seeing some science images coming in later this summer. And the current goal is about 10 years in operation. Part of the deployment heading out there, they were able to save a little bit of fuel, so it looks like they might be able to extend the lifetime of the mission a little bit, which is really exciting because it's always good to eke out every ounce of science you can when you spend this long and this much money getting something out into space. So as we are going to be talking all about the first images, these will hopefully prep you to these activities we're going to be covering today. Will prep you for when those first science images start coming in later this summer.
Great, thank you, Dylan. Okay, so we are going to jump in to the activities. There are, as I said earlier, there are 4 activities in this toolkit, and Just like with the first two, all of them are accompanied by a fundamental science concepts blog that you can just reference as a little cheat sheet for how these activities fit in with the JWST mission. And they each come with modification and preparation lists if you're looking for different ways to maybe have take-and-make kits, in-person programs, or virtual programs. So I also forgot to introduce Beatrice. She is also one of the StarNet team members joining us today, and she will be dropping the link bank in the chat periodically. So if you want to look at any of the activities or the accompanying blogs or mod lists, check out that the link bank. Yes, it's in the chat, so you can click on that now. But the first of our 4 activities today is called Improv with the Stars. So this is a little bit different than other activities that we've included in previous toolkits. This is a really fun kinesthetic activity where you invite patrons to come up and act. So this is best done in person. In this activity, patrons learn about stellar classifications. So the different types of stars and the different characteristics that they have. Then a group of patrons acts out an improvisation of a specific star type. And then the audience guesses which star type is which. So to talk a little bit about the science connections in this activity, some of the basics are stars are different colors depending on temperature. So similar to how, the hotter parts of a fire, of a flame is blue, the biggest and hottest stars are blue as well. The temperature of the outer layers of a star does generally directly relate to its mass. So the most massive, biggest stars are the hottest and are blue, and they are given letters for their type. So O type stars and B type stars are those big, big, big blue ones that are very, very hot. And then the smallest stars are the coolest, and they are red. So those are given the letters K and M. And then there are several stars in between too, including our own sun. So you can kind of see here on this image, the biggest, hottest stars, that's called the O stars. And then it goes all the way down to the little small stars that are red, classified as M. Can anyone tell me what type our sun is? Between M, K, G, F, A, B, and O, what do you think our sun is? Christine is not sure.
No, you didn't read the whole thing. I said, G, not.
Oh, I see. You put a little hint in there. So if anyone, there's a very good hint in Christine's. Yes, Karen, yes, I'll guess G. That is correct. Our sun is a G type star. So it is on the kind of the smaller end, not quite as hot as some of these big stars out there. So yeah, that's our little sun right there. So a couple other things just to note in the science for this activity. Stars do change or evolve over their lifespans. So smaller stars will get a little bit bigger. They'll expand into red giants, and large blue stars eventually become red supergiants. Small stars, though they may be small and not as hot, they do have slower reaction rates, meaning that they will have a much longer lifespan than those big, huge O-type stars. There's a lot of reaction happening here. So they're big and they're hot and they burn out really quickly. Whereas these smaller stars can last for a really long time because they're not burning through their fuel quite as much. So those small stars have slower reaction rates, and the smallest stars that formed over 13 billion years ago are actually still around. So even though they're small, they kind of keep going and going and going and going. And Christine mentioned in the chat, our sun will eventually get so big that Mercury, Venus, and Earth will be inside of it. Wow. Yes, Susan says, when I was a kid, that used to terrify me. Same, Susan. I remember the first time I learned that like the sun will engulf us. I was like, didn't quite understand time and how long that will take in comparison to a human life. And yeah, it can be scary to think about. All right, so in this activity, there are actually there's I think like 6 or 7 like star personas that the actors in the improv game can act out. We have selected 3 to demonstrate for you today. So the 3 star personas that Stephanie, my colleague, and myself will be acting one of these. So you have to choose which of these 3 stars we're acting as. We're each acting as a different one. So the first option is Zeta, and this is a star type O class. So again, this big circle over here, it's the largest, brightest, hottest, and most rare star. The color is blue. It is 6 times hotter than the sun and 19 times bigger than the sun. And so Zeta, as a young star at only 3 million years old, so young, is actually likely to die in another 3 million years because it consumes fuel very quickly. So that is your first option. Next, we just have the sun. So again, this is a type G class. It is yellowish white or off-white in color. It is 333,000 times bigger than the Earth. And it is, of course, the brightest and closest star in the sky from where we can see it. And it is orbited by 8 planets. The sun is 4.5 billion years old and will live for another 5.5 billion more years before it becomes a red giant, blows off its outer layers, and ends as a white dwarf. So quite a bit older than Zeta and will live quite a bit longer than Zeta. And the third star persona is Proxima Centauri. So this is an M class, the little tiniest that you can see up here in this image. It is red. It is about half the sun's temperature, and it's about 0.12 times the sun. So it's much smaller than the sun. But it is older. It is 4.85 billion years old and expected to live about 3 trillion years. So small, but old, and will continue its journey in space for a very long time. All right, so I'm going to stop sharing and spotlight Stephanie and myself. So try to keep in your mind those 3 star types that I shared. So Zeta, the big, very young one, burning through fuel really quickly. The sun, medium size, it's going to live for quite a few more billion years. And then, of course, Proxima Centauri, the tiny star that will live a very, very long time. So now we're going to start an improv act for you all, and we would like you to guess which of those 3 stars we are acting out. Oh man, we're on this elevator and it just stopped. I think it's stuck.
I do not have time for this to be stopped. I've got to get my coffee. I got to get to set. I got to get these things done. I mean, I am a big star, so they need to get this thing moving. I don't have time.
Wow, you do sound like you have a lot going on. I really hope that this elevator starts soon because I do have 8 kids at home waiting for me, but I've got some time. I want things to be safe. Let's just hope that they can fix this elevator safely.
Safe is all relative. We don't have time for safety. We've got to get moving. We've got things to do. I mean, I don't have time for this. I've got to be on set in 5 minutes, and I've already blown them off before because, well, when you're a star like me, you don't have time to listen to what all those other little people do. So we need to get this going. You know how to call them? I think there's a way to call them. Is there a button to call them? You have kids. Do you know how to do that?
Wow, you must be a really big star. It sounds like you have a lot going on, but we will figure this out. We will. And you bought a bag of donuts that you're really eating through those really quickly. You might want to slow down there,
Oh, no.
You're gonna make yourself sick.
Oh, no, no, no. My metabolism is through the roof. I can eat all of this and not gain a pound. I know people hate me for it, but what can I say? I've been doing this for a very long time, but yeah, we got to get going.
Yeah, I should probably check on my kids. You know, I have even some grandkids, my dwarf, call them my dwarves. Yeah, Pluto really has been a little bit needy these days, feeling a little left out. So I should probably get home and help them. I know you have a lot going on too, but you know, we really want to think about the grandkids too.
Man, if you have that many kids, how long have you been around?
A long time. I know. It seems like just yesterday. Uh, my 8 kids, I should mention, they're all grown up already. I'm just so proud of them.
Could you, I know you have your 8 kids, but could you like move over? We don't have enough room in this elevator for all of me right now.
I'll try. You are taking up a lot of space in here. Whew. It's pretty hot just standing right next to you, I have to say.
I know. They love it.
And I think the elevator doors just opened.
And scene.
See,
All
there is
right.
my theater minor coming out for all y'all.
Please, everyone give a huge round of applause to our wonderful, wonderful improvisers. Big round of applause, big round of applause.
All right, thanks everybody. All right, I would like to invite you to make your guesses. Which of those 3 star types do you think we were? I'll put them back up on the screen too, if you need to think about it.
And you can unpin us. Hi, everybody, but I don't need to be front and center anymore.
Okay, yes. Oops. Go ahead. All right, so your options for guessing are Zeta, the big blue hot star that is going to burn out in the next 3 million years. The sun, which we're all very familiar with, that has 8 planets orbiting it. Or Proxima Centauri, the little tiny M-class star. All right, who has some guesses? Who was Stephanie? All right, and Susan is saying, it was easy to see the big star Zeta was Stephanie, and Claire made a very responsible son. Yes, thank you, Susan, you got it. That was a lot of fun. Thanks, Stephanie. But yeah, that's how this game works. And in the activity, there are also little cards you can print out to give to the patrons who are guessing, and they can write down notes. They can circle which star they think they are. But so there are resources within the activity to help the audience guess who is who. And there are many different star types within the activity guide, not just these 3. So you can have multiple people playing at the same time. It also has different improv games that you can choose from. So Stephanie and I chose to do that. We're stuck on an elevator game. But there's another one listed on there as well. Plus in the modification and prep list, we put a link to different improvisational games. So you can try out a bunch of different kind of storylines to have your patrons act out the games. All right, so that's Improv with the Stars. Next, we have Multiwavelength Bingo, and I'm going to turn it over to Dylan to describe this activity.
All right, so Multi-Wavelength Bingo is a really fantastic activity that uses basically a bingo game to teach all about how we look at different things in the sky through different wavelengths of light, using different lengths of light and measuring those wavelengths of light to get different views of the same object. So included, all of everything you need is printable right in the activity guide. It's got the, if you look in the photo here, it's got rules and background information on the different types of stars, and even includes a little link where it lists links to supplemental information. The flashcards, which contain references for all of the stellar bodies you will be looking at in the game. The bingo tokens with the NASA logo. Bingo cards, there's 6 of them in here. So you can either, if you're doing this for a large group, you can have people play in teams, especially as there's a little bit of a hunting and investigation portion to the game. It's a really great group activity. And then finally, the bingo calling cards that have the image on there, as well as the name of the the celestial object and the type of light that particular image is capturing. So this is played just like regular bingo, but instead of calling out B5, I12 or something like that, instead of an alphanumeric combination, it's a combination of a particular feature of the sky and then a type of image that the type of image that it was taken, whether or not that's optical, infrared, a composite, or X-ray. So if you want to go ahead and spotlight me, we are going to be going through just a simple kind of demo of how to do a bingo on this game. So everyone should see the bingo card right here. So it's a pretty standard bingo card, 5x5 grid, free space in the middle. And thank you, Beatrice. Beatrice has just put in the chat a link to the activity guide, and I'm going to ask everyone to open that up so we can so you can see the reference cards on there. Oh, Susan has a note. One note, I think, on the cartwheel galaxy flashcard, the composite image has the name of the galaxy, but it doesn't say composite. You can tell from the bingo calling card. Oh, excellent note. Thank you. I did not realize that that was. I think. Oh, interesting. I did not notice that the first time we went around this. So yeah, the composite is missing on that reference card. That's a good catch, Susan. Thank you so much. So if you open up in that activity, that's going to have the reference cards, which are on page 3 and 4 of the activity guide. And what we're going to do is I'm going to call out a few of these, and I want, if you guys can find them, see if you can find them. I'm going to zoom in a little bit on here so you get a little better view. What I'm going to ask you to do, I'm going to call out a couple of bingos, or a couple of spaces, just like we were doing the game, and I want to see if y'all can find them on the card using those reference cards in the activity guide. So first, let's try and find Cassiopeia A in infrared. So can anybody tell me where in position that might be on the card? Go ahead and throw it in the chat. We're looking for Cassiopeia A in infrared. Top left side. Very good, Barbara. That's excellent. So we got that. Yep, that's right there. So as you can see on the calling card, we have Cassiopeia A in infrared. And that's right. That's the top left side right there. Oh, and you know what I forgot to do? Always the best thing. Got to fill that free space. All right, let's look for the cartwheel galaxy in composite. Actually, the one that Susan was just talking about. So this is, if you want to cheat, this is going to be the one without a label on your reference card. So let's look for which one you think is the composite galaxy, or the composite image of the cartwheel galaxy. And if you don't want to put it in the chat, you can just unmute. We're a small group here. G4. Excellent. Yeah, the right here, that's the composite image of the cartwheel galaxy. All right, how about we do, this is going to be a different view of Cassiopeia A. We're now looking for the X-ray view of Cassiopeia A. So you're going to go to that Cassiopeia A reference card and look for which one is the X-ray, and go ahead and tell me where I can find that on this bingo card.
Dylan, is it N2? I'm having a hard time seeing.
It's actually, I think on here it's the
I2. Yeah, I figured it was one of the two. I'm very nearsighted.
No problem, but no, that's very true. Yeah, that second one down in the second row column is it. And you might have guessed where this last one will be, but we're now looking for another image of the cartwheel galaxy. We're looking for that X-ray image of the cartwheel galaxy. Anyone want to take a guess? Bottom right, yeah, that's right, Claire. There we go, and there we got a nice bingo on there. Woohoo! Congratulations, everyone. Your prize is my smile. So that is basically how you play multi-wavelength bingo. As you can see, there's like kind of that hunting component using the reference card. So this is a really great group activity, especially for like teens and tweens, where you might give 2 or 3 of them a bingo card each. Or if you've got a small enough group, an individual bingo card, and you can explore the different ways, just like James Webb Space Telescope is using a variety of infrared and near infrared instruments to look deep into space. This has a nice overview of how we've looked at different wavelengths of light throughout the galaxy, and sometimes further. So that is multi-wavelength bingo, the science of which Christine is going to be going into as that science crosses over with our next activity, filtered light. So I'll turn this over to Christine.
Thank you, Dylan. Thank you so much. And yeah, so for all of you, if you're doing this multi-wavelength bingo game with younger kids, maybe you could, or with mixed ages, maybe you could actually show them the picture of what you're calling. And that way, all they have to do is match the picture. And there might be other modifications you might need to make if you have participants who are color, who can't see colors all that well. But so a little bit behind this here, we see different features in different wavelengths. And so here in this picture, you can see two sides of galaxy 101 and 101. You can see part of it in a sort of a visible composite and part of it in a different wavelength, a wavelength that isn't visible to our eyes. But astronomers use all these different images to tell us more about them. So things that are higher energy and shorter wavelengths might be violent explosions of a supernova or gas and dust being pulled apart, ripped apart by a black hole. Invisible light, stars shine invisible light, and most of their light, and galaxies that are shining, you know, out of stars that they're made from. Same thing, we're seeing visible light there. But in lower energy levels and longer wavelengths, we get things like clouds of gas and dust that are being warmed by new stars inside of them, or being expelled from a galaxy. So lots of different things that we can tell from these types of pictures. Next slide, please, Claire. And we wanted to let you know sort of some of the pieces here. All of these different types of light, when we're talking about different wavelengths, these make up what's called the electromagnetic spectrum. These types of light are also sometimes called radiation, and visible light is just a tiny bit of it. Radio waves are really long wavelengths, and again, low energy levels there in terms of what's going on. Infrared, there's a lot of infrared light out there, and that's what we're going to be looking at with the James Webb Space Telescope predominantly. Ultraviolet is more energetic than visible light in terms of you might have heard of something called E = mc². The amount of energy in the photons of light from ultraviolet is higher, and the wavelengths are shorter. And X-rays and then gamma rays are the most powerful in many ways. And our atmosphere protects us from most of these things, which is why telescopes on Earth can't see a lot of them. And instead, we have to put them into space above the Earth to see some of these. Next slide, please. So we have a whole lot of different telescopes out there to see these different types of light, to see the gamma rays, to see the X-rays. You might have heard of Chandra, an X-ray telescope, a telescope that's studying the universe in X-rays, for instance. You've heard of the Hubble Space Telescope, which has been looking at the universe in visible light and a little bit in infrared. There used to be one called Spitzer that's been retired, and it was studying infrared, our universe in infrared light. But the new telescope, the new space telescope, is going to be predominantly seeing in infrared, and it's replacing the retired Spitzer telescope. And it's so much bigger, it's going to be able to see so much more so much more distant, and so much more clearly. Next slide, please. So the activity that we just did had all of these different pictures, and some of them were combinations of different wavelengths, and some of them were, just a narrow band of some of these different wavelengths, and they were telling us different things. An astronomer can look at this, and each picture tells them something different about whatever that object is, and that's why we do it. Does anyone have any questions for Dylan or for me, or comments to make about this activity? But all of this information is going to feed into filtered light. Comments to share about how you might do it, or changes or questions for Dylan on the work that they did in terms of putting the game together?
Christine.
Yes,
so
please.
we're probably going to try this at our James Webb Space Telescope event this summer. This was one of the activities that I reviewed, and I really like your idea about showing the pictures. I think we're probably going to modify it that way. The other consideration was maybe just having more flashcards too. So it shows, one set per, but I think I'll have multiple sets handy, because it, when you were testing it and we were looking, and I was trying to switch back and forth between the bingo and then having to find my PDF, it can be challenging. And so if you have, some real quick moving people, they can definitely have an advantage over someone that needs a little more time. So I think it helps to make sure that everyone has access to the flashcards. But I think this activity is a lot of fun, and I like that it's visual, and you don't necessarily need to be a reader to find it, especially if you have pictures and make modifications.
Great points. Thank you so much for sharing, Susan. I appreciate that.
Oh, you're welcome. Thank you.
Susan, I think you bring up a great point too, that you don't necessarily need to be a reader. This is a really great way to involve multiple types of learning in a single activity, especially if you're doing this for maybe a family audience, or you have maybe multiple ages of participants, especially younger participants. This is a really great way to bring different types of learners together in a way that's like creative and problem solving in a visual milieu. Like, as you can see of these, the examples of the calling cards here on the screen, it's a really great opportunity for maybe a tween or a teen to develop some leadership skills, leading a group of maybe younger learners, and then or helping find, matching the visuals with the science behind it, if maybe the younger learners are not necessarily at the reading level of the activity. So I think it's a really great opportunity to bring groups together, and who doesn't love playing some bingo?
Dylan, I agree with you. And one thing I want to add, my background is as a scientist, and I'm really into getting people to feel like they're scientists too. And so during our summer family fun programs, when we do our science and STEM activities, I like to have people think about how they can be a scientist too. And a lot of times, this was true for me anyway, that I felt like because I wasn't very quantitative or mathematical, that I couldn't be science. But it turns out that there is a lot of room for visual people, and for being able to interpret and compare images and do problem solving that way. So it might be fun, if you're visiting with your library patrons and kids and families, to talk about, there are different ways to do science and different skills. And I think that that this is a great activity for emphasizing that too.
And also a great way for people with different skills to work together to achieve a goal, which is also a really important point to emphasize.
You can have them work in lab teams, maybe of 2 or 3, depending. And then that could make it more cooperative and less competitive.
These are wonderful points. Thank you all. We're going to move on now to the next activity a little bit, but I like some of the other comments here about books, about what is a scientist, and quotes about scientists having fun, all these different things to incorporate into your programs. Thank you all so much. So this last activity, we talked about these different telescopes and how they see in different types of light. This next activity, exploring the universe filtered light, allows us to block out some of those colors, those wavelengths of light, and focus on others. And it sort of emphasizes how filters can tell us a little bit more about an object. Next slide, please. And so I'm going to give you a couple of examples here, and then Dylan is going to give us some examples in person that are even better. So here we have a beautiful picture, one of the pictures that comes with the kit. And I have tried to, in the next slide, move like one of the filters over on top, the blue filter. And as I did, you might be able to see some features more clearly on the next slide. So when this happens, are certain features that you see more strongly? What pops out for you when you're looking at it with that blue filter on it? Which features of this image do you see more of? Do you see more of like the red things or more of the blue things? What do they look kind of blobby or strandy, or how would you describe them? Do you see more or less of the stars? Any thoughts? Just a little bit less bright with the blue. Everything looks dimmer. Absolutely. Everything looks dimmer. That is true. Do you see how the blue blobs there underneath the blue kind of seem to almost be glowing a little bit more compared to the rest of it? Or is that just me? It could just be me too. It could be you do see that? Yeah. Let's try the next slide and see how this looks for the next slide in comparison. And for this one, when I'm looking at it, I don't see those blue blobs quite so much. Instead, I see those red strands a little bit more, way less blue blobs. Yeah. And then, so different filters will reduce how much we see some of those colors of light, in this case, some of those wavelengths of light, and make it easier to see others. Let's go to Dylan's example. So I'm going to be quiet now, and we're going to stop sharing these slides, and let's take a look at what Dylan's got for us to see even better.
All right, so I have here the 3 images that are included in the activity. These are all composite images from different stations. This one is composite from Chandra, Hubble, and Magellan. And these ones, this is Hubble, this guy is also Chandra. So these are all composite images, which are really great for doing this kind of activity with, because it's composited from measuring different wavelengths. So if we look at some of these, like this Phoenix galaxy cluster, for example, I take a look at this guy and I think, well, okay, that's very blue. So if I put this under a blue filter, you can see, as we looked at in the example that Christine showed, you get a lot more, some of these features really, really come out a lot brighter. Versus when you put the red filter on, those blue features get a lot darker, and you see everything gets a little more washed out when you're looking at this particular images under the red. And these are just some simple light filters. You can find these similar, these are just theater gels. I think I got this in a multi-pack for about $10 online. So it's a pretty easy way to find these filters. And as you can see, it's so I would definitely recommend going through some of these images, looking at them regular, asking your patrons what kind of features they notice and how those features change as you filter different light through them. Then you can also do your own art extension. Here I have a piece of cardstock, and I've used a pretty simple pink and red highlighter to just create 2 different color images over each other. This is my favorite part as well, Christine. And what I really like about this is you can do, I've done something really simple here, but you could actually even do 2 full images, whole drawings on here, one in pink, one in red. And what you'll see is when you put those filters over, one of those images disappears. which is always so fun. It is a real wow moment with patrons when you show them this, and especially kids when they see just how they can do this and create this kind of their own filtered art is really cool. And if you do want to do an extension, if you happen to have any old 3D comics in your library, there was a real phase in the 80s and 90s where they were doing red and blue 3D comics with those old-fashioned or secret messages are another way at this. The science behind this filtered light activity is exactly the same as those 3D comics or secret messages. Except in the 3D comics, you have one lens that is red, one lens is blue. So each eye gets filtered, a certain color filtered out, and that creates an illusion of depth. Or in the case of secret messages, when you cover that up with the red or blue, it reveals, you have the blue text covered by like a red spackle kind of thing, so it's illegible. So you cover that with a red piece of plastic, and then suddenly you can read the blue. So there's a lot of opportunities for maybe you to use some archival maybe comics, or they can create their own art if you wanted to try and attempt to get some 3D glasses and have them create their own 3D art with this. That is another option you can do as an extension of this activity. So that's filtered light.
Thank you, Dylan. Claire, I've got a couple more slides that go with this and some of the science behind it again, just to reemphasize why we do this. So we use these different filters to learn more about what something in space is made out of or what its temperature is. So here you can see a composite image surrounded by different images taken with different filters, different telescopes, different settings that are revealing different aspects. In some cases, they show us more about the center and what's going on. In some cases, they show us more about the outside. And here what's going on for this galaxy is the areas around the outside that in the yellow image are really bright. Those are areas where new stars are forming, and those big giant class O and class B stars are exploding in supernova. Lots of stuff is going on the outside of that galaxy. Whereas as you get closer to the middle and the inside of the galaxy, it's mostly old stars and gas and dust that are showing up in the red picture compared to the green and the blue and the yellow where you see all the new stars forming. So we learn different things from the different types of light. And the next slide, another example that some of you have experienced with me before. Susan, I think we've talked about this before. Barbara, we may have. You can have your kids do their own little experiment to see infrared light. So if you happen to have a remote nearby, and during a Zoom call, during a virtual presentation, and you can look at it with your eyes, you may not see anything. When I'm looking at this one, I'm holding down the power button, I'm not seeing anything. But when I shine it on the camera, I do see a light that's blinking. That light is invisible to me, but it is visible to the camera. Now, if I use a cell phone to look at it, I can't see it on my phone because my phone has a filter preventing me from seeing it. But if you have, a lot of the Apple phones have filters to prevent you from seeing the infrared because it makes the pictures prettier without that. It's got a filter on it. But if you have it with another type of phone, your phone might be able to see that infrared light glowing too. It depends on whether your phone has that filter in it or not. So one more example that you can try on your own with your computer camera, with, when you're doing Zoom or holding a virtual meeting, or you can try it with your cell phone and see if it works. Any questions or comments about this, about filtered light as an activity for Dylan or for me or for Claire, before we move on to the last activity? Claire, why don't we go ahead on to the next activity and we can continue discussion on all of them after.
All right, so the final activity we're going to talk about is my personal favorite activity because I love a paper craft. It's a foldable paper model of the James Webb Space Telescope. So it's a printable foldable JWST. We have both full color, which is the version in this example photo right here. We've also created a black and white version that is just the outline of all the pieces. You can color it yourself. I would definitely say the full color model is appropriate for maybe tweens and up, upper elementary, but the black and white version, we created that partially so that it can be adapted for a more all ages audience. It's a really great opportunity to maybe have younger patrons color the model while older patrons cut and assemble it. And it's a really, really fun way to learn about the basic parts of the JWST. So there's 4 basic parts of the activity. You're going to cut out the outline, fold along the dotted lines, glue the pieces that have the dots, and then you just assemble the space telescope model. Can we move on to the next slide? So the model represents the 3 main sections of the JWST. We have the spacecraft bus and antenna, which is on the sun-facing side of the sun shield. The sun shield itself, which is this gray piece here and this pink diamond piece over here. And those represent the sun shield, which is really, really vital for JWST to function as the third and final part, the primary mirror array and the scientific instruments have to be kept very, 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 very cold. So while JWST is in orbit, it's actually, while we see it all the time with the mirror array on top, the sun shield and the spacecraft kind of underneath is kind of the orientation we see it in terms of how it's facing the sun, the antenna, solar panels, and the spacecraft bus are all facing the sun, and the sun shield blocks all light going to the mirror and the scientific instruments. This is really important because, as we've discussed, this is an infrared camera, and heat can create infrared, interference when you're trying to gather infrared light. So all of those instruments need to be kept very, 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 very cold and have no light, because light is going to create heat. Photons contain energy, which can create heat. So all of that dark side of the JWST has to be kept really, really cold. And there's tons of more information in the blog we've released about this, about all the different instruments on JWST, why it needs to be kept cold, its journey out to Lagrange point 2. Those are all included in the background science blog for this activity. So we can go ahead and spotlight one more time. I'm going to show off a physical copy of this model. So here we have, this is what it looks like when you print it out. There's virtually no instructions. It's pretty straightforward. As you can see, you're going to fold along all the dotted lines and glue where these dots are. Here we have a page with the antenna setup and the spacecraft bus. That's this part beneath here. The cold-facing side of the sun shield. So this is where all of the mirror array and the instruments will sit on. The sun-facing side of the sun shield. So this is where obviously the solar panels, where to generate energy for the JWST are located. And here is the mirror array and the scientific instruments containment. So you have the gold mirrors of the primary mirrors here, and here this setup, which represents the secondary mirror, which then reflects back to the images taken by the primary mirror back into the instruments for processing. Let me show you what these all look. We also have the black and white version of this. So here you can see what this looks like in black and white. This is, I've removed all the color from these, so it's still got the dotted lines and the dots to glue on, but you can color this in yourself any way you'd like. Let me go ahead and show off what these cut pieces like and give you a couple of tips on how to assemble this. So here's what everything looks like once you've cut it out from the guide. So here we have the spacecraft bus again, the cold-facing side of the sun shield. Here's the antenna array, the mirror, the primary mirror and the scientific instruments, and the secondary mirror. So there's a couple of notes that I want to make sure that we emphasize for you. There's a couple of places that you need to cut here that aren't the clearest, especially on the primary mirror array and the cold-facing, the cold side of the sun shield. In these parts here, which all fold down, there is a line here you're going to need to cut at the edge of the sun shield in order to fold this piece down for gluing. And it's not really clear that you need to cut there. And there's a similar piece on the edges here of the mirror array. So just make sure that you're not cutting on this dotted line here. That's a fold line. You want to cut the piece here so that you can fold that triangle down. It's also, it's not so clear, but you actually need to fold these just a little bit, not a full fold for the secondary mirror. You just want to give that a light fold. So when you're attaching that, and I'll show you on the completed model, when you're attaching that here to the primary mirror array, not a full fold, but just a slight bend can make that a lot easier to attach. So let me show you off a couple of completed models. So here is what the full color JWST looks like when you've assembled the full model. So here we have that primary mirror array. Here you can see that attachment the secondary mirror makes right here to the mirror array and the scientific instruments. Here's the sun shield. Again, we've got, you imagine my fist is the sun back here. This is how the spacecraft will be oriented as it rotates around the sun. It actually rotates like this around Lagrange point 2. There's some great explainer videos explaining that in the blog, linked at the end of the blog for this activity. So we have the sun shield here, and then the spacecraft bus, and then this little antenna right here. Oh, and one more tip about the antenna. The round part of the antenna, the broadcasting dish, it's a lot easier to attach if you cut it just a little bit. I can see here on camera. Cut it just a little bit right here so that you can kind of make a cone with it as you're attaching it to the antenna portion. And then if you wanted to color your own, I've made this, you know, it's almost June, it's almost Pride Month, so I've made what I'm calling the John Waters Space Telescope. Make it a little bit for Pride Month. We have, so this is what it looks like when you create your own color design for the JWST, which is always a fun activity. Thank you, Sarah. I thought it was cute too. I might just hold on to this and put this in my home somewhere. So that is, Barbara said, oh, and glue sticks rather than liquid glue when assembling at the library. Yep, that's a very, very good point. You can also use, I've been, do glue dots would work for this. I actually found the most success with double-sided tape. I cut myself a bunch of lengths of double-sided tape. And as I was assembling, I just put the double-sided tape on the section of the, I can actually, why don't I show off one more time? If you cut some double-sided tape, just some strips of double-sided tape to put along here before you fold, that gets a lot less messy, and it's a little easier to deal with as you're trying to assemble. Sometimes that liquid glue, especially as you're trying to assemble, it can get onto the ink portion. If you're doing the full color version, that glue can kind of rub some of the ink off. Not the prettiest, but yeah, glue sticks, glue dots, or double-sided tape, or even just taking regular Scotch tape, creating, you do the trick where you take a double-sided tape, roll it into a tube, and use that to attach along here. Those are also great ways to attach this. Whatever you have around is a pretty good one, but liquid glue, probably the messiest and the least fun option for cleanup. So that is the JWST model. And once again, I want to emphasize we have a lot more in-depth science about the different components of JWST, which are all included in that background science blog, including some really great videos linked there at the end that go into in-depth about the mission, the science and engineering behind JWST. That are really, really informative, and also really great to just, if you have a large TV or a projector, you can project those videos while you're doing this activity so people can learn about the JWST while they're making their own. And that's the JWST model.
Great, thank you, Dylan. So that is all 4 of our activities for this toolkit. I want to turn it over to our NASA at My Library 1.0 mentors. We've been hearing from you all throughout the program, so I appreciate your tips and tricks, but if anybody wants to unmute themselves, that's Susan Borders, Susan Rolfsmeyer, and Barbara Shatara, or you can put it in the chat, but any recommendations you have or how you would do any of these activities in your library, we'd love to hear from you.
So I'd already offered some input on the bingo, but I think it'd be really fun to do the bingo and the filtered light activities together, or at least kind of, you know, if you do multiple events, because I think they follow each other up really well. I can say that we did the model and it was a lot of fun. It was really successful, and the tweens and older elementary school kids really enjoyed it. You might need to help them with the creasing, and it helps to have something you can use to rub those creases and get them really firm, so you get a nice line, and to be there to support people who might have difficulty with those fine motor skills would be a good modification for that.
What I found is really helpful as I was assembling my models is I have a cork backed metal ruler. So if you have something like a really nice thin firm edge to fold those creases along, that makes it a lot easier, especially if you're dealing with younger people with maybe some less fine motor skills.
Yes, I agree with you, Dylan. And then once it's assembled, it's really a lot of fun to play with.
Awesome. Thank you, Susan. Barbara, I did see that you had unmuted yourself. You want to share out any thoughts?
Sure. When I was reading through the improv for the stars with the stars, which I love, by the way, is really funny and fun. I was thinking that, you know, for some of the programs that we do, we have like stations around. And I thought one modification for it could be that you have like people dressed up, you know, as their star, and, you know, kind of talking. And as people go to those stations, they could interview the star, or the star could just be saying things that they have to then guess. And then maybe they would get a little prize if they got it right. You know, there's a lot of creativity you can do with that particular one. And it also reminds me of when my son was in elementary school, we used to do science projects for him in class. A couple parents would do it, and we'd have a little skit to begin with, and to get the kids' attention and sort of talk about the ideas that we would be discussing through the course of the lesson. And so I thought, you know, this would also work really well with schools, you know, if you're doing collaborative work with local schools, and certainly during the summer, having, you know, maybe getting a group of kids to, you know, practice being the stars, and then presenting it as a larger program. So there's a lot of different options for it.
Great.
When I first, oh, sorry.
Oh, go ahead.
I was going to add, Claire, when I first read that activity, I'd felt so intimidated by the different sizes of the stars and the letters, and thinking that I would have to memorize all those things. But then seeing it acted out really changed my perspective. So I'm really glad that you demonstrated this, because I think that this makes it a lot more accessible and possible, something that we could do at the library.
Great. I'm so glad to hear you say that. Yeah, sometimes you just need to see it in action. All right. Well, thank you so much. And I know Susan Border has been dropping stuff in the chat throughout about her suggestions. But Susan Borders, if you want to add anything, we would love to hear it. And for the last final little bit, I am going to launch a poll because we always like to see which of these activities that you're most excited about, so that we can continue developing resources and curating activities that will work for your libraries. So feel free to answer in the poll. And this is a multi-answer. You can answer more than one answer. You can select more than one answer. But the question is, which activities are you most excited about? And again, the options are Improv with the Stars, Multiwavelength Bingo, Filtered Light, and NASA's James Webb Space Telescope model. So I'll keep this up for just a few more seconds. And thank you, Sarah Wall, for joining us. All right, looks like everyone has answered, so I'm going to end the poll and share the results. Looks like everyone selected filtered light. That is very exciting. That is an activity that was developed by NISENet. They did a great job with it. So I'm glad to see that that resonated. And I'm always happy to see every single activity got selected at least once. So we're hopeful that these can be useful to you when celebrating the James Webb Space Telescope at your library. All right. Well, that is all we have for you today. So check out that link bank. Beatrice, if you could drop that just one more time in the chat, that has all of the activities, all of the resources available. It also has the contact information for Dylan, Christine, and myself. So if you have any questions, please reach out to us. And a big thank you to our mentors, Barbara and Susan Wolfsmeyer and Susan Borders. So it looks like she took off, but we appreciate having you here and just telling us, sharing your expertise as working in the library. So.
And if you haven't, please check out starnetlibraries.org. We have a ton of resources there, like the STEM Activity Clearinghouse, which has collections for both the JWST, Look Up, Explore Our Universe, and specifically a collection for this first image. We have recorded webinars, including all of our previous JWST webinars, our events with AMNH around the launch of JWST, as well as the Look Up event page, which has links to all of the fantastic resources we've developed around JWST here at StarNet.
Great. Thanks, everybody. Have a great rest of your day.